Welcome to today's lesson. In this first tutorial, we will find the discriminant and use the value to describe the nature of the roots for a quadratic equation. So we are in our fourth method of solving a quadratic. We're going to be using the quadratic formula today. And the standard form, let's review the standard form for a quadratic first. We have our ax squared, which is our quadratic term, plus bx, which is our linear term, plus c, which is just our constant term, equal to 0. It's going to be very important for us to be able to find our coefficients a, b, and c today so that we can use our quadratic formula. And here it is. The quadratic formula that will find both of our solutions or roots or zeros or x-intercepts if they happen to be real is right here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. That is our quadratic formula. Now it's pretty cool that it's a formula because that means that it will never change. The only things that will change are the values of a and b and c, and that of course comes from our coefficients. Now I did say that there are two solutions. Do you see that there are two solutions in our formula? I hope so, because we're using that plus or minus symbol. So the opposite of b plus the square root divided by 2a is one of the solutions, and the opposite of b minus the square root divided by 2a is the other solution. So here's our quadratic formula. Please memorize that. What I like to do first is find what's called the discriminant. The discriminant is the expression underneath the radical. We call it the radicand. Anything underneath a radical sign is called a radicand. So I'm talking about the b squared minus 4ac part of our quadratic formula. I like to find the discriminant because it will tell me the nature of my solutions or roots or zeros. When I find the discriminant, if I get that the discriminant has a positive value, meaning that it's greater than 0, then that means we will have two real roots. I'll use the word roots. Two real roots. Now we can go a step further with this. If they're going to be real, then we'd like to know if they're going to be rational or irrational. So once we know that we have a positive discriminant, a positive value underneath this square root, we know that we have two real roots. There's two types of positive numbers that we could have. We could have a positive number that is a perfect square. Perfect squares are things like 1, 4, 9, 16, 25, 36, and so on. And if it is a positive and a perfect square, then we will have two real rational roots. Two real rational roots. Rational meaning that they are nice. They have a terminating decimal or a repeating decimal. Rational feels good. If it is any other number, I'll just say not a perfect square. For example, 2 or 3 or 5, 6, 7, 8. Or 10, 11, 12, 13, 14, 15, all the numbers that are in between the perfect squares. We still have two real roots, of course, but now they are irrational. Ultimately meaning that the square root symbol will remain in our answer. We'll have a square root of 3 or a square root of 11 or some sort of radicand. The stuff underneath the square root is actually equal to 0. Well, if you have something that's equal to 0, you have the square root of 0. The square root of 0 is just 0. And this part of our formula basically just goes away, and we would just have the opposite of b plus 0 or minus 0. Well, that just means that we just have the opposite of b, and that's divided by 2a. So if we have this, we're going to have one real rational root. One real rational root. Sometimes we call it a double root because it's the same number that solves our equation twice. We always have two solutions, but in this case, the two solutions actually appear as just one number. And then our final case, if we get that the discriminant is something less than 0, meaning that it is a negative. If we have the square root of a negative, then we know we're in imaginary land, and we would have two complex roots. Oops, roots. Something that will involve I, the imaginary number. So I like to find the discriminant first so that I can describe the roots. And there are only 4 choices. We either have 2 real rational roots, 2 real irrational roots, 1 real rational root, or 2 complex roots. And that's it for this tutorial. We're going to solve our quadratic equations using our quadratic formula in our second tutorial. Thanks for watching this about the discriminant. See ya.